CSEC Mathematics, May 2025. We're at question 8. It says the following diagram shows the graph of the function y equals x squared plus x minus 2. Okay, good. Let's say, from the graph, state the roots of the function. Alright, so question 8a, the roots. Well, in this case, 8a1 for question 8a1. Let's just write the roots over here. It's negative 2, x equals negative 2 and x equals 1. X equals negative 2 and x equals 1. Those are the roots. That's where the function is equal to 0. That's where the graph of the function intersects the x-axis. Alright? The coordinates of the y-intercept of the function. The y-intercept is where the curve cuts the y-axis. You can see it here is negative 2. That would be part 1a, part 1b. So y equals negative 2. Let's just write them down over here. Okay. Now, the minimum value of the function is going to be part C, the minimum value. That's the lowest point. Alright, so let's look at this. Of between 0 and 2, you have 1, 2, 3, 4, 5 small divisions. So that's 1/5 of 2. Alright? Now, that's 2/5. 2 divided by 5 is 0.4. So it's like we're going 0.4, 0.8, 4, 3 still 1.2, 1.6, and 1.6 plus 0.4 gives you 2. So each small division is 0.4. So this minimum value is at, it's a little below negative 0.2. What is it? It's negative 2.4. Alright? That's negative 2.4. C is negative 2.4. So the minimum value is negative 2.4. Alright. The equation of the axis of symmetry of the function. You just to state it so you can write it down directly from the graph. Now the minimum value, you can see it halfway between negative 1 and 0. Now, halfway between negative 1 and 0, you have 1, 2, 3, 4, 5 divisions again. Now, from 0 to negative 1 would be 1 centimeter. So each small division is 1/5 of a centimeter. What is 1/5? 1/5 is 0.2. So if we do that, going 0.2, 0.4, 0.6, 0.8, 1.0. Alright? Now, going to the left, you have 0.2, 0.4. But it's not a full 0.6. You're going halfway across. Halfway of 0.2, which is 0.1. So it's 0.2 plus 0.1, which is 0.5. Another way to look at it is the fact that you're halfway between 0 and 1, which is, between 0 and negative 1, it is negative 0.5, negative half, right? So what you have here is negative 0.5. That's it. Oh, the equation of the axis of symmetry, x equal, is x equal negative 0.5, right? Okay. Now they say on the same pair of axes on page 24, draw and label the line y equals 2x plus 4. Alright, page 24, that's this. Let's copy it from here and paste it over here. Alright, so they say the graph of y equals 2x plus 4. Draw and label that. Well, we can do, write down y equals 2x plus 4. So we have y equals 2x plus 4. Now, let us see what happens when at x, let's rewrite it this way. When x is equal to 0, we choose 2 points or 3 points just to make sure we don't make any mistake. X is 0. Y is equal to 2 times 0 plus 4. 2, 0 is 0, and we have 4. So when x is 0, y is 4. So 1 point on it. When x is 0, y is 4. So we plot this point. Let's see another point. When y is 0, what is x? 0 is equal to 2x plus 4. If we subtract 4 from both sides, we say negative 4 is equal to 2x. Divide by 2. Negative 4 over 2 is equal to x. So x would be negative 2. So 1 point was 0 and 4. Another point we locate is when x is negative 2, y is 0. So negative 2, 0. So negative 2, 0. Oh, that's this point here. Good. Let us just look at one more point. What is y when x is 4? When x is 4. When x is 4, y equals 2 times 4 plus 4, which is 8 plus 4, which is 12. So another point on the line would be x equal 4, y equal 12, 4, 12. So 4, 12 would be here. Let's draw our new line now. Let's redo this. Okay. So we have our new line. Alright. So here, on the same axis, you draw and label y equals 2x plus 4. Let's say label it, so you have to write down, let's label it down here, y equals 2x plus, oh, what we do, you see, let's extend this down. We don't want too much writing in this region. So let's extend this thing down and write y equals 2x plus 4 here. Alright. Y equals 2x plus 4. After that, let's say, using your graph, determine the solutions of the following pair of simultaneous equations. Y equals x squared plus x plus 2. That's the original function, y equals x squared plus x, well, minus 2, right? Right, minus 2. And y equals 2x plus 4. Alright, so the solutions would be what x would be. So for 1b2, so that would be question 1. No, that's question, this is question 1. Question 8. So it is 8b2, right? That question 8b2. For question 8b2, one solution would be when x is when you have them intersect, x is equal to -2. That's, we have x equals -2 and x equals let me just write, since I said it, and x equal, this would be right here, and x equals 3, because that's where they intersect again, and x equals 3. Alright, -2 and 3, those would be where they intersect. Okay, now here, part C. The following diagram. All right. The following diagram, and by the way, let me look back. Yeah, -2 and 3, good. So a different thing now they're asking you about. So the following diagram shows the velocity time graph of a car's journey from town R to town Q. The car accelerates for 2 minutes, travels at a constant maximum speed, then slows to a stop. Determine the initial acceleration of the car. Alright, let's just clear the screen here and copy this thing and work with it on the other screen. I want to copy all of it. Alright. Copy and paste it here. Okay. Alright, so what they say is determine the acceleration, initial acceleration of the car. That's for 2 marks. Initial acceleration of the car. Now here, you have to remember certain things, right? And of course, it would help you if you did physics, because this is really a physics type question, right? We know that velocity or speed is distance divided by time. At the same time, acceleration is a change of velocity with time. So it's velocity over time, which is distance over time, right? But anyway, acceleration is velocity over time, changing velocity over time. Now, if you change velocity, well, this is speed, so let's put it as speed, all right, instead of velocity. Remember, velocity is speed in a specific direction, but they say speed, so let's put s instead of v. Now, change. If you want a change, let's put a little triangle to say delta. All right, delta v. The acceleration is delta s over delta t. Changing s or changing time. Now the change in speed would be the 30 minus 0. 30 minus 0 over change in time during that period is 120 seconds over 0 second. Minus 0 second, I said over 0 second, it should be minus 0 second, right? Which is really the gradient of that line. So 30 over 120, this would be 3 over 12, which is 3 into 3, 1, 3 into 12, 4, a quarter, right? So acceleration is 0.25 meters per second squared, okay? Remember, that's a unit for acceleration, right? That's the initial acceleration of the car, 0.5 meter per second squared. Okay, calculate the distance between the two towns for 2 marks. Distance between the two towns. Now, we're going to need this space. All right, let's just draw a line to separate this from the other pieces of the work. To calculate the distance between the two towns. All right, let me increase this a bit before I copy it. Distance between the two towns. Alright, so let's drag this down here. Now the thing is, know that distance is equal to speed multiplied by time. Alright. Now, here, if you say speed multiplied by time, and what's happening? Oh boy, my mistake. Accidentally. Speed multiplied by time. This is a graph with the vertical axis labeled speed and the horizontal axis labeled time. When we have a graph such as that, where we have speed and time. If you say speed by time, speed represents the height, of this rectangle, and time the width. It is really height times width. So the distance is really the area under the graph. Is really the area under the graph. Alright? You see that? So we're going to find the area under the graph. We have 3 pieces of area here. We can cut the graph so that we have this part where have 0, it goes up to 30 and goes across to 120. The height is 30, goes 120 second. So remember, this is speed, meter per second, time in seconds. So this goes up to 30 meter per second, 120 seconds. This was 0. Alright. Then the middle part of the graph would look something like this. It goes from 120 up to 5, well, each of them is 60, so 600, from 120 to 600. So this is 120 to 600, and the height is the same, 30. And then the last part of the graph, if we cut it, this would of course be at 600, but where does it end? Remember, we're cutting it this way. This comes right along here, 600 to, now each of these boxes is 60, so it's 780 plus 60. 780 plus 60, 0 and 0, 0, 8 and 6. It's 14, bring down the 4, carry 1, 7, 1, 8. 840, this is really 840, right here. It's 840. To 840, alright? So, here now, we're going to do the calculation. Call this A1, A2, A3. A1 is half times the base 120 times the height 30 equal half of 120 is 60. 60 times 30, which is 63, is 1800. 1800. Alright. A2 now. A2 would be 600 minus 120 to get the width times the height 30. It's the same height, 30, right? Alright, so that would be 600 minus 120 equal 480 times 30 equal 1440. Equal 400 is so? My 14400, right? And by the way, what's the unit? Well, distance is speed by time, meter per second times second. Remember, is meter per second times second. Second, we cancel second, leaving meters, right? So it's in meters. These dots keep appearing there. Meter, meter, and then A3. Area is the same as distance. You could already, might as well call it D1, D2, D3. Same thing. Alright. So A3 would be half the base, half of 840 minus 600 times the height of 30, which is what? 840 minus 600 is equal to 240 times 0.5, which is half. 120 times 30 equals 3,600. You have 3,600. Alright. So total area equals total distance, which is, it would be 1800 plus 14,400 plus 3,600. So the distance equals, and you add up these things, 1800 plus 14,400 plus 3,600 equals 19,800. Alright, so it's 19,800 meters, which would be 19.8 kilometers. Alright, so that is that. And that is it for question 8. We look at question 9 next time.